Hello, this is Feng, one of the designers and developers of Pyleoclim. In this presentation, I'd like to give a brief introduction of the Pyleoclim user interface, focusing on what it is, why we designed it like this, and how to use it and make your paleo data analysis life easier. So, what is Pyleoclim UI? Well, we know that Pyleoclim contains a collection of powerful data analysis functionalities on the hood, but it is easy to get lost when you are facing so many tools. You may have many question marks, such as which method should I use, when should I use it, how should I apply the method, and what should I apply the method to. Pyleoclim UI provides an interface that allows users to utilize these functionalities at a higher level, making it easier to construct workflows that are concise and clear. To achieve that, it takes an object-oriented programming design, or OOP. The idea of OOP is much simpler than its name. The concept is to treat an item as an object. Then naturally we can apply a collection of methods on that object with certain arguments. For instance, if we'd like to describe the chess move that queen moves from the d1 square to the d3 square, then the pseudocode might be like this. Here queen is the object, dot forward is the method that applies, distance is the argument for the method, and 2 is the input parameter. We may have more daily life examples. For instance, picture.take n equals to 1 means to take a picture. Coffee.drink n equals to 1 means to drink a cup of coffee. And a cup.put into closet means to put the cup into the closet. Note that closet here is also an object like the cup, and the closet is used as an input parameter for the method. So why OOP? Why we took this specific design in Pyleoclim UI? Well, based on the daily life examples you see, the advantages of this design is clear. It makes the code very concise and readable. It follows the natural relationship between an object and a method. You cannot drink a picture, can you? Also, each call is a clearly defined action, and you can easily combine those calls together to construct workflows. The universe of Pyleoclim UI looks like this. Here we see several different objects shaped as squares, along with different methods shaped as hexagons. Some methods are for pre-processing, some are for analysis, and some are for visualization. Taking series here as an example, which refers to a paleoclimate time series object and is a typical start point of a time series analysis task. First of all, once we got this series object, we can immediately plot it with the plot method, after which we may perform some pre-processing steps such as detraining and standardization. The output of those methods is still a series object, and we may plot again. Or we can perform a spatial analysis and call the spatial method, which will return a power spatial density object, or PSD. In addition to the series object, sometimes you may want to deal with several time series at once, and that's when you may want to use the multiple series object. Sometimes you may have an ensemble of time series, and there's also the ensemble series object for you. Overall, this diagram serves as a roadmap of the Pyleoclim universe. In code, the typical workflow we mentioned earlier looks like this. We first define a series object, specifying the time axis and the value axis. Then we make a plot quickly, and realize that we need to detrain and standardize, after which we perform the spatial analysis and then plot the result. That is neat, but life can be even easier, thanks to the method cascading feature. As you see here, since each method will return an object, those separate steps in the previous slide can be combined into a one-liner like this. So that's about it. Thank you very much for your attention.